Hi, Assalamualaikum and hello to Dr. Arif. My name is Ahmad Afif Jazimin bin Kashii and we are from Group 1 consists of me, Lim Kai Peng, Lauziru and Muhammad Nazri of this course Thermodynamics and Mechanics of Material Laboratory. So today we want to present about the experiment for which is application of first and second laws of thermodynamics. The first part is introduction. The objective of this experiment to apply the first and second laws of thermodynamics in various processes. The scope of this experiment. The first one is the experiment is conducted under ideal conditions, assuming no heat loss to the surroundings and zero thermal resistance. Number two, the temperature of the hot water is 100 degrees Celsius while the cold water is at ambient temperature which is 25 degrees Celsius. Number three, the pressure is constant at atmospheric pressure. And the last one is the data will be recorded at 1 minute intervals until the system reach its equilibrium temperature.
I will present about the theory in this experiment. The first law of thermodynamics defines that heat energy cannot be created or destroyed, but it can be transferred from one point to another point. According to classical thermodynamics, heat exchange between a system and its surrounding minus the work done by or on the system is equal to the total change in internal energy of a system. If the object is moving, then it would involve the kinetic energy and potential energy, and vice versa. Thermodynamics consists of Kelvin Planck statement which state that it's impossible to convert heat energy into work completely, and Clausius statement which state that it's impossible that temperature transfer from a cold region to a hot region. In this experiment, we assume that it's a closed system, no motion and elevation, and the equilibrium temperature will be achieved in the end of experiment. This is the formula derivation based on our assumptions in this experiment. The equation we will apply in discussion later.
The next part is experimental setup. As you can see in the figure 1, in this experiment we use number 1 is beaker, number 2 is balance, number 3 is thermometer, number 4 is heater, and the last one, number 5 is large container.
Step 1. The mass of the empty beaker and empty large container were measured and recorded. Step 2. The empty beaker was placed in the large container and filled in the cold water until 400 milliliters reading of the empty beaker. Step 3. The empty beaker was then taken out. The mass and the initial temperature of the large container and cold water were measured and recorded. Step 4. The hot water was then prepared by using kettle. Step 5. The boiled hot water was then filled into the empty beaker. The mass and the initial temperature of the beaker was measured and recorded. Step 6. The beaker with hot water was quickly placed back into the large container with cold water. Step 7. 2 thermometers were placed separately in cold and hot water. The change in temperature for both hot and cold water were recorded for every 1 minute time interval. In this experiment, we use method 2 to get the accurate result.
The table shown is the result table we obtained from the experiment. As expected, the temperature of hot water decreased and cold water increased. After 80 minutes, thermal equilibrium is achieved. Here's a guide to calculating temperature changes in hot and cold water. Begin by recording the temperature of the hot water at 1 minute as TH1. Subtract the initial temperature of the hot water, TH2, from TH1 to find the first temperature change. Repeat this process for subsequent time intervals, such as comparing the temperature at 2 minutes with that at 1 minute and so on. Here is a graph plotted by referring the data. From the graph, we can see the temperature of hot water decrease and cold water increase. It is obvious that hot water takes longer time to achieve thermal equilibrium than cold water. This is because the high specific heat capacity of water. More energy is required for hot water to be lost and reduce 1 degree Celsius. Based on the graph, temperature change is displayed, which has proven the first law of thermodynamics, as it indicates heat is transferred from one place to another place. Based on the graph, there is an abnormal plot. The yellow box shows a sudden increase in temperature of hot water and the green box shows a sudden decrease in temperature for cold water. The reason this scenario occurred is because our hand was shaking while holding the thermometer during the experiment. According to natural convection within the water, temperature at top and bottom region are different. That's why we obtain an abnormal plot for the temperature change. Now we will calculate the change in energy in order to prove the second law of thermodynamics. There are some constant values we recorded to determine the mass of hot water and cold water. You may pause the video to look at the calculation. We now apply the equation delta U equals to mCp T2 minus T1 to find both the energy change in hot and cold water. For hot water, we obtain a negative value of 71.18 kJ, while for cold water, we obtain a positive value of 44.41 kJ. You may pause the video to look through the calculation. By adding both the energy change in the hot and cold water, we will be able to find the thermal energy change of the system. It is obvious that the thermal energy change is not equals to zero, which obeys the Kelvin-Planck statement. It is impossible to convert heat energy into work completely. Besides, the negative value of thermal energy indicates temperature is flow from hot to cold region, which has obeyed the Clausius statement.
For our conclusion of this experiment, from the plotted graph change in temperature of hot and cold water, there is the region which caused the temperature not stable. This might be caused by several errors occurred during the experiment. The objective of this experiment was achieved and considered success due to first and second laws of thermodynamics was proven. The energy transfers from hot water to cold water to reach the thermal equilibrium state in this experiment was achieved. To improve the accuracy of the result obtained from the experiment, first, the reading of the thermometer should be taken at the eye level that is perpendicular to our eyes to avoid the parallax error. Second, place a thermometer with the object that can hold it when measured for the hot and cold water to avoid the error. The last part is safety procedures. Number one, personal protective equipment PPE. The student need to wear appropriate PPE for experiment and wear a closed-toe shoe. Number two, handle the apparatus carefully. The student need to avoid breaking any apparatus, avoid missing any apparatus, and report to lab assistant if the thermometer is broken. Number three, report any injury. The student need to report to lab assistant to get the first aid treatment if accident occur. Number 4. Pour the hot water carefully. The student need to wear gloves when holding the hot beaker to avoid spilling hot water. And number 5. Tidy up. The student need to clean the work area and return all equipment to designated place after the experiment. This is our reference throughout the experiment.
Appendix, which is data of the result getting in the experiment.
Kincana ting ning 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 ning. Ku menahan rasa sakit